So I'm here at Rockaway Beach in New York. It's about 6:30 p.m. right now. I just got out of the water, and the waters are incredibly warm. Like right now, I'm standing in the water. It literally feels like I am in Florida. It's incredibly warm. I can't describe it. It's like bath water. It's like it's in the 80s almost. I mean, I'm touching it with my hands, and it doesn't feel cold. Like, it's crazy how warm the waters are. I mean, despite this overcast and all the winds coming off the water, here at Rockaway Beach, the temperature is 78 degrees, almost 80. The water temperatures are close to 80 degrees right now. The buoy that is 20, like all the way out there, 20 miles, 30 miles out there, nautical miles, a buoy that is 6 feet deep, so 6 foot in depth. Those are rocks. Those are storm break rocks for hurricanes. And see, after Sandy, thank God it was weak. Were you under a warning, Johnny? Anyway, water temperatures here in New York are right around 80 degrees. The buoy all the way out there at 6 foot depth, water temperatures are between 76 and 78 degrees. Yet here, where I'm standing here, water temperatures are in the low 80s. This is incredible. Immediate coastal water temperatures are close to 80 degrees. I mean, the winds are coming in from the southeast right now. We're having an east-southeast wind right now, and winds upper level are coming from the south. But this is incredible. People really don't care about the climate. You know, as a student at the Boston Agashi School, I was really concerned about the environment, and I got 2 recycling programs started. I mean, it's continuing to this day. While I made a tiny positive impact, I wanted to do so much more. You know, I wanted solar panels erected. I mean, this was years and years ago. I even tried to petition the school. I wanted to start a fundraiser to put solar panels up on the roof. This was back in 2007. When climate change was not such a hot topic issue. It was for me. Climate change, global warming, correct term I think, it should be global warming, has always been a hot topic issue for me. And it's not just global warming, it's anthropogenic global warming or climate change. Whatever you call it, it's 100% anthropogenic, 100% man-made. Look at Mauna Loa. Look at the amount of carbon dioxide at the Mauna Loa or Mauna Loa Observatory. Going up and up and up every year. We are at 416, near 417 parts per million at this moment. While the increase this year over last year isn't as drastic as 2018 over 2019, that is because of the coronavirus pandemic slightly limiting the amount of CO2 we are producing. But that's only making a tiny difference. Our CO2 concentrations are still going up because we are still pumping CO2 into the atmosphere. And look at this. Water temperatures are in the almost 80 degrees. And here's the thing. We are entering an active phase of the Atlantic. The warm phase of the Atlantic is kicking in. And even though water temperatures have never been this warm before in history, even when water temperatures 80 years ago were cooler, like in the low 70s around here, or upper 60s to low 70s, you had Category 2, Category 3 hurricanes racing up the coast. And now, with water temperatures warming every year, for example, there was a buoy that was in, not New York Bay, but near Belmar, that registered 84 degrees last summer. And the buoy out there registered 79. At this time, it was around 75, and now it's already at 78. We are getting warmer and warmer and warmer. The water temperatures here are conducive for tropical development. And there's never been a time in history that North Mid-Atlantic waters are warm enough for tropical development. I think this used to be once in every few decade occurrence. Because as a kid, I would remember The warmest it ever got for New York Harbor entrance pool was maybe 75 degrees. And now it's easily getting very close to 80. Like, it's dangerously warm. It's getting warm to the point that you're even finding sand moles, which are tropical creatures. I'm gonna show you what I'm talking about. I'm gonna dig for some sand crabs, and I'm gonna show you what I'm talking about. These are not normal for this area. Sand crabs are normally found in tropical waters, and yet we're finding them here in the Northeast. I've been finding them even 10 years ago, but they're becoming more and more common. Sand crabs, whereas they're known as, forgot their scientific name, they go by different names: sand moles, sand crabs. They're basically little crustaceans that dig in the sand. They don't look like crabs. They look like arthropods, basically. They look like, and they have a hard shell. They don't bite or to pinch. But they've been regularly at the beach, usually at the water's edge during high tide. So they would normally come up to about here. This is where they would usually be, right around that area. I'm trying to find them. Yeah, but this is low tide, and they're usually found where the high tide is. Yep, I think I found one. Let's see. It's better to use your hand because shovels can actually hurt the crustaceans. Okay. Let's see. Yeah, I'm probably gonna have to be a little further up the sandbank. Yeah, looks like I can't find any here, unfortunately. They used to be found here at Rockaway, but yeah, I forgot with all these rocks. I used to found them on Beach 100th Street, about where, by by the Cross Bay Bridge. Yeah, I forgot. Usually find them further away from the rocks. But look, you're finding, mussels. But mussels and crabs are usually found on both shores of the United States. I'm gonna try to go further down. And look at that. Oh, I've also been finding jellyfish washing ashore, but jellyfish can be found in cooler climates too. So of course I took mass transit here. I don't need a car. I don't want a car, as that's really bad for the environment. People should really be following Greta Thunberg's example. And also governments need to build better mass transit, like the way they tried to do it in the early 1800s. Early 1900s. Trains are very important, especially high-speed trains. The United States needs to invest in high-speed transit for trains, because planes are horrible for the environment. They can only transport a limited people at a time. You need multiple flights, and they could only at most fit maybe 100 to 150 people. Yet a train, especially a high-speed train, could use 1/10 the energy of a commercial jetliner, travel at approximately the same speeds, perhaps even faster, if it's a maglev, and also transport the same amount of people. So it is very, very like economically sensible to build high-speed transit. The only thing that's going to be expensive for it is to build rails. You need to build, the existing infrastructure is going to be expensive. They did it in Japan. They did it in Europe. Why can't they do it in the United States, especially on the East Coast? I mean, you could also use high-speed trains. Only thing you really need to do in the United States is upgrade the rail. You don't have to have elevator tracks or, do all the crazy infrastructure for high-speed trains. You could have high-speed trains that go up to 150, 200 miles an hour on regular tracks, on just different steel grade tracks. That's all. You don't need to build all these crazy architectural stuff, For example, in France, most of the trains run on the ground, like regular trains do. So it is very, very possible to build a high-speed train that can go at least up to 150 miles an hour and have it use electricity, solar power and also internal electric power, or having a Zentograph, power lines above the train. That shouldn't cost too much. I'm not talking about building a maglev. I'm just talking about building high-speed transit in the United States. You know how much it's going to cost to use high-speed transit, to upgrade the rails, or just make some modification to the trains? It's only going to cost a few $1 billion. And yet the savings to the environment would be in the hundreds of billions, perhaps in trillions of dollars in the long run. And also, it'll be better for transport, especially you could have a local track, you could have an express track. It's like you could build new rail too, which may cost a little bit more. Or you could just build more tracks alongside. So you'll have a local track for intermediate stops, like between New York and Chicago. You could have a local train that'll make more intermediate stops, or an express train that will only make 1 or 2 stops along the way. And you don't need to spend hundreds of billions of dollars or even trillions of dollars to upgrade, to build new rail. You really don't. You could use existing rail and only build new rail to run alongside for the express tracks. And it could also be on the ground. You don't have to build bridges or tunnels. The only upgrades you may need to do are to build barriers instead of little crossing gates. You could have maybe metallic barriers at the crossing gates, at the train crossings, so car wouldn't run in the path of the train. That's all. And that can cost what? A few thousand, maybe a few $1 million at each stop? Maybe $10 million, $20 million? And that's probably going to be some of the cost. Also labor. If you're going to factor everything in, the difference between building completely new infrastructure, like a bridge or like maglev, that's going to be hundreds of billions of dollars. Still, that's economically feasible, considering that Bill Gates and Jeff Bezos alone have almost $1 trillion in their GDP. I mean, come on. Yeah, the beach is beautiful. Thank you. Well, climate change though the climate does naturally fluctuate from time to time due to asteroid strikes, volcanic eruptions, fluctuations in solar activity, what is not normal is the current amount of CO2 that is in the atmosphere. Only in the last 50 years. Even the Siberian traps that erupted 500 million years ago that caused the largest mass extinction event ever recorded, just as large as the asteroid impact. In fact, the asteroid impact, the Chicxulub impact, had less of a climate impact than the Siberian Traps eruption, which pumped so much CO2 in the atmosphere. And it wasn't during the regular phase of the eruption, it was during one of the outgassing events. And it caused a major climate catastrophe. Why? CO2 in the atmosphere, ocean acidification, global warming. Volcanoes did that, but it was not like a Kilauea eruption. Literally, the eruptions covered an area of a whole continent. Imagine the entire United States covered in nothing but lava. Yeah, those don't happen anymore. Those haven't happened in millions and millions of years. Flood basalts are next to humanity the biggest threat should they occur again. But a flood basalt event are not occurring. Even in Iceland, they're not flood basalt events. They are volcanic eruptions from fissures, from hotspot. While a flood basalt, especially the Siberian Traps, wasn't a result of a regular hotspot. It was a result of several mega plumes. Not one hotspot, but like a basically like a mantle wave, like a whole, not a little thin hotspot that goes up like that. But I'm talking about an entire like magma blob. So it's basically extremely important how we protect our environment, because the amount of CO2 we are pumping out outpaces all volcanic activity on the face of the earth, all of it. Had we not been here right now, or had we not been having all this mass infrastructure, CO2 in the atmosphere would be around 280 ppm right now, 280 parts per million. Yet we are in the low 400s. We contributed to about 40% of the amount of CO2 in the atmosphere. I mean, it's not too late. You know, we could stop before we hit 500, but if we go past 500, there is no turning back. If we go past 450, there is no turning back. We need to stop it before we hit 450, before we hit 440. We should try to cap it at maybe, I think, for the planet to survive without massive loss of life to species, to us, we need to stop the amount of carbon dioxide we pump into the atmosphere immediately, and let natural variations do it instead. Let the nature pump and take out CO2. We should not be contributing to it. Let nature do it. And we must also try to not only reduce, but try to take out the CO2 that we already pumped in. Well, transitioning to clean energy, to safe nuclear technology that doesn't need all this pressurization and coolant, meltdown-proof reactors, basically. But nuclear energy should not be the main source of energy. The main source of energy should be geothermal, hydrothermal, using the Earth's interior heat for our energy sources. It should be solar, wind. That's what we need to do, especially geothermal energy, which actually has more potential than solar, of course, because even though solar energy goes all over the world, the amount of land you'll need is extremely high. The most efficient form of energy is obviously going to be geothermal or hydrothermal or of course nuclear energy. But the most efficient form of transport is trains. Absolutely, especially not the trains that America has, which are diesel powered. But even those trains are more efficient than cars and buses and planes. Trains are still the most efficient form of transport, even the diesel ones. But the best form of trains are, of course, electric, the ones Europe uses. Because even those trains produce less CO2 than, say, gas cars do. Because gasoline-powered cars pump out so much CO2 per passenger, it's crazy. The next best option after cars are buses. Next best after buses are planes. On average, a plane that's fully packed 80 to 90% or near 100% capacity is about as efficient as maybe a 4-cylinder car that has maybe 4 people in it. So the only difference between between cars and planes is what is better for the environment. I mean, if you're flying on some of the most fuel efficient planes, you're basically, let's say you have a hybrid. Yeah, it's even the most fuel efficient plane today is still nowhere as fuel efficient as a hybrid car or an electric bus or a large fuel efficient bus. So what we need to do is we need to do everything we can to protect the climate, because right now, there are already signs that are bad. Waters off New York are getting to record temperatures. Just look at last year. Go to National Data Buoy Center. Go to any buoy and look at its history, and you'll see the warmest temps have only occurred in the last few years. Go back as far as you want. You're not going to find water anything above like 78 degrees, from when the record is being from when the records first began being kept until now. There was nothing above 78 degrees. I mean, maybe it happened in the 1930s and 1940s, but that's speculative. It's happening now, and it hasn't happened in the last 40, 50 years. I mean, right now we are in the warm phase of the Atlantic, or supposed to be in the warm phase of the Atlantic. And it's crazy warm. Like, even in the cool phase of the Pacific, the La Nina we're having isn't even really a La Nina. Because while the immediate Pacific, the waters are warm, cool, you're having a La Nina, most of the Pacific is still very warm. The only area of cool water, basically, is the immediate equator off the coast of South America. That's where you're having the La Nina. So basically, the warmest, the coolest waters right now in the Pacific are in the ENSO region, the El Nino and the ENSO region, basically. The ENSO regions right now are experiencing a La Nina. Pretty potent one too, but it's only in that area. You're not having a whole bunch of cold water spilling everywhere. In fact, southern Mexico, the waters off southern Mexico are incredibly warm. So warm, in fact, they're talking about a major hurricane developing, despite being a La Nina, when hurricanes activity in the eastern Pacific should be suppressed heavily. So you're still having the effects of global warming on the environment. You're still having the effect of global warming, man-made global warming, on the oceans, on land. We've always had severe weather, tornadoes, hailstorms, damaging wind events. But I'm talking about temperature events. Global average temperatures have been steadily increasing since satellite records began in the late 70s. They haven't really been going down. They've been going up. Like, you've had little variations, but the variations are going up, like up, down, like this. It's really still going up. And CO2 in the atmosphere has been doing the same thing. The general trend is increasing. You're having already global temperatures are following this trend, a exponential increase trend. Maybe it's not going to be suddenly like that, but you're going to have eventually the warming will become exponential eventually, as you're going to have runaway global warming. You're going to have other feedback loops that are going to basically cause a runaway greenhouse effect. And as it gets worse, temperatures are going to continue to increase. And the only thing we can do is try to limit our carbon footprint now. instead of waiting another 20, 30 years of inaction and for it to be too late. The Republican Party, all they care about is the oil and gas industry and the people who rely on it. Why not, have those people who dig for coal instead maybe work in the wind or solar industry, or work, for a different industry that's not bad for the environment. Instead of digging for coal, why can't they be digging for rare earths that are going to be used in fighting global warming, like lithium, for lithium-ion batteries? Lithium-ion batteries are very important because they can be used in energy storage, and lithium-ion isn't even the most important element for energy storage. It's actually, believe it or not, carbon. Carbon is a much better facilitator than lithium. Why don't you utilize carbon as a capacitor, as a supercapacitor, for energy storage, for energy transfer? Especially graphite, or graphene, as it's going to be known. Graphene is basically going to be a wonder material. It's going to be basically the plastic of the 21st century. It's going to be it's not going to be like plastic, how it's going to degrade the environment. In fact, it's actually going to save it. You're not going to need rare earths. You're not going to need to dig for anything. You could use a carbon from the atmosphere. Like, you'll have to dig. Like, the coal that we use should be sufficient. You don't have to dig for rare earths, destroy new things. Just use one lump of coal that will probably only allow a light bulb to light up for maybe a half a second, would allow you to probably make a whole graphene battery that will last you years and years and years. And then it will make solar energy very feasible. It will make wind energy very feasible, especially energy storage and transfer. So eventually, wind and renewables, and when I mean eventually, I don't mean 30, 40 years down the line, it should be less than 10. We should be completely phasing out fossil fuel cars by the 2030s. We should be, if we're even going to be using internal combustion, it should be biodiesel or biofuels only, even if. But I'm all in favor of completely banning all internal combustion engines. Because ICE engines, internal combustion engines, cause so much health dangers for people. You're smelling all those chemicals when you're pumping gas. People are saying that, electric cars, they cause cancer because of the EMF. It's actually low frequency radiation, which is actually less harmful to health than, say, visible light. Visible light is higher frequency, which means it has higher energy. Some people are sensitive to low frequency electromagnetic fields, but they don't cause cancer. They don't cause mutations. So they therefore don't cause cancer. So, in fact, see, they don't cause cancer, so that's a conspiracy. The fact that the claim that they cause cancer, like electric cars, is actually a conspiracy theory that was spread around by people that are paid by the oil and gas industry, or people that are against, progress. People that want continue to drive internal combustion engines. A lot of the things, my mom made that claim, and where she got it from ended up being a site that was funded by fossil fuels. So, for example, my professor who's teaching at LaGuardia Community College got a book that was from this religious institution about climate change denial, and yet they were telling her, that climate change isn't real, that it's natural, that what's going on now is natural. Guess where that school is funded from largely? Oil and gas industry. Yep. Whenever you're hearing climate change denial, make sure you look at where it's coming from. Is it coming from like, the international community from public, research projects, or is it privately funded, like for oil and gas? Yes, you're going to have solar, you're going to have, special interest groups that are in favor of green energy. But at least they're not spreading misinformation like the oil and gas industry is, because they're a behemoth. They're like a freaking, it's like the United States versus like a country, like a tiny little city, Well, the fossil fuel industry is losing its grip slowly but surely. They're going to do things to become more desperate. They're like, how they're going to use greenwashing techniques, like what BP did. Oh, we support the environment. We're supporting diversifying our energy resources. Yeah, they're really actually still after oil and gas. They're not for diversifying anything. They're not diversifying anything. If we truly care about this planet, we need to boycott, the fossil fuel industry, boycott buying internal combustion cars, demand electric vehicles more and more and more, until eventually that's all that's going to be made. Also demand more for green energy. Call your senators, call businessmen, call everyone to pressure them into ending gas and oil exploration.